So unit number 4, force, and unit number 5, friction. Both at once we're gonna take because both the lessons are physics and connected to one another. And the tools given for you also consisting of the notes from both the chapters. Okay, force and friction. So the word force, it is not a new word for you. You are learning about this from the lower grades on. Okay. And here we are going to learn about some specific laws and equations and the calculations. So mainly two parts in this chapter. One, we learn about the force. First, we learn about what is force, what are the principles, what are the laws. And then a small part connected to that, the mass and weight. Mass and weight. So, we started with the word force. What is called force? What is called force? Force is simply a pull or a push. All our works we are doing would be going up with either a pull or a push. Right? Either a pull or a. What is a pull? Pull means? Is it a pull? No. Mostly the people, they are having a problem with this pull and push type. When you are going into the supermarkets, the pharmacies, stalls and all, you see, pull and push, it's mentioned. Mention pull, you keep pushing. Mention push, you keep pulling. That's goodness, the dough is not coming on your hand, right? Okay. So you see, pull and push, always you are having a problem. So what is this pull and push? Let's say you are applying a force. Okay, you are applying a force on an object towards yourself. You may be directing towards the object or in the opposite direction, but still you are giving the force towards you. Either this way you are pulling, or else standing behind you keep pulling on, right? So the force you apply towards yourself is called a pull, and you are giving a force away from yourself. Okay, it's away from yourself. It is a push. Two kids are there. First one keeps pulling the object while the second one keeps pushing the object. Okay. So the positions also may change. He is moving, moving forward, keep pulling on. He can change like this and moving backward also. Moving backward, keep pulling on. So same way this person, the second kid, he keep pushing forward. He can do the same thing. Being behind, he can keep pushing. Okay. So ultimately, what is the task here? If the force is applied towards yourself is a pull, away from yourself is a push. Is that push? Clear the point? Alright. Now related to this force, there are some coins. So let me take that in a simple diagram this way. An object. There's a person, right? He's applying a force. He's applying a force. The force is applied towards himself. Towards himself. Force is F, and this is towards. It is what we term as a pull. It is a pull. Right? It is a pull. Another person. Let's say I'm just changing the position here. What he does, he is also giving a force. He is also giving a force away from himself. The force is given away from himself. How do we name this force? It is a. You can see the position doesn't matter. What is the direction related to the object? The force is given accordingly. We take it as a pull-up. And is it always on a horizontal line? No, it may be vertical, in a diagonal, angle, whatever. Any place towards you, pull away from you. Okay. So I say, when you come for a force, at all, any planes you can do this, right? A drawer you are going to open. A door, a window you are going to open towards you. Is it a pull or a push? It's a pull. Some examples, simple examples. You are closing it. Away from yourself, you are giving the force, right? It's a push. Sliding doors are there, you are standing here, you are pulling it. And you are moving it. It's a push. You are riding, pull and push. Also pull and push. Throwing something. Throwing a ball. Kicking on a football. Kicking on a ball. Push. It's a push. Right? lifting up something, lifting the bar in the exercises. Okay, any object you are lifting, it's a pull. Something you are going to compress, you are compressing. You are compressing. It's also force. It's also force, right? So now you see the bicycle we term it as the push bicycle, right? No, sir, it's not push. Push bicycle. Push bicycle. You are saying push bicycle or something? Push bicycle. Yeah, it is not push bicycle, it's push. Or else foot cycle. You are saying foot cycle. Why foot you are using? What are you doing with your foot then? You keep paddling, right? Is it a push or a pull? That's a push. You push. You give a push. So it is a pushing bicycle. It doesn't mean you are getting down the bicycle, keep pushing. So what is the use of a bicycle? Yeah, being seated by your feet, you keep pushing. So it moves forward. So remember, it is not push cycle, it is push bicycle. Got it? So pushing bicycle or foot cycle. Right. Fine. So all these things are either pull or push. Brushing teeth, pull and push. So whenever you are brushing in the morning, see pull and push. So you see, pull and push, everything. Right? So any object, when you are playing or throwing away, it's a push. Right? So all the works are done accordingly. And this force you take, is it a scalar quantity or a vector quantity? It is a vector quantity. It is a vector quantity. Vector quantity means having a magnitude and a direction. Having a magnitude and a direction. So you see, the force is a vector quantity. And this force, it is symbolized by capital F. Symbolized by capital F. And what is the measuring unit? The measuring unit of force is newtons. Capital N. Capital N. Newtons we use to measure this own force. And remember, 1 kilogram we take this the unit of mass. 1 kilogram is equal to how many newtons? 10 newtons. So just roughly remember this. Calculations we will be taking later. Okay. 1 kilogram is equal to 10 newton. 2 kilograms equal to 20 newton. 10 kilograms equal 100 newton. Okay. How this 10 comes later with the calculation we will take. Now, this is the measuring unit. What is the measuring equipment? The measuring equipment is the Newton's spring balance. The Newton's scale, Newton's spring balance. It is calibrated in such a way, according to the mass you keep, there will be a weight given. There will be a weight given due to gravity term. Right. That is what, as the second part of the chapter, mass and weight, you have to learn. Right. Now, I said it is a vector quantity. Being a vector quantity, it has mainly 2 points. What are 2 points? It has a magnitude. It is having a magnitude. That is what we measure in newtons. And it has a direction. A definite direction is there. A definite direction is there, and this direction, for one direction, if you take it as a positive value, the opposite direction is gonna be a negative value. To my right, if it is plus, to my left, it would be minus. And remember, this is taken on one line, one plane. You can't take 2 planes like vertically up, horizontally to the left, you can't take. You can't take in the sense, you can't make it plus minus. There may be forces acting, but you can't take one as plus, the other one as minus, because it should be on one line. One line, either horizontal or vertical, one line. Then concerning to the same or opposite direction, you have to take plus minus. Okay, you have to take plus minus. So you see, these are some basic ideas. Along with this, another one is there. And this is not because of vector, additionally. The point of application of force. What do you mean by the point of application of force? Point of application of the force means that is the exact point where you apply the force on an object. Right? Now you see, we can graphically represent that. This is just an example. This graph we take. The magnitude is shown by the length of the straight line. So you have to increase or decrease according to the scale. Arrowhead shows the direction. Can you see the arrowhead? Shows the direction. Okay. And the point of application is shown by the dot here. Can you see it's dot where it is contacted? So whenever you are drawing, make sure the straight line is contacting either a pull or a push. It is contacting object. Halfway through, you can't. Let's say this is the object. I'm giving the force here. Object's moving. Where is the force applied? This is the point. So this is called the point of application. Point of application of force. So that point of application of force is indicated by a dot. Actually, that is grade 9. Grade 9 you have learned. So you are using that knowledge in grade 10 as well. Right. So accordingly, these are some fundamental parts of whom the force. Now, is it just because of a force you apply an object is moving? Just you apply a force, object won't be moving. It depends. It depends. Object to object, it's different. So an object is moving because of a new word for you, unbalanced force. What balanced force? Unbalanced. Remember, any object moves by a pull or a push because of an unbalanced force. What is this unbalanced? Unbalanced means not balanced, right? That means something should have been balanced already. After balancing, what is the excess is unbalanced. You understand the word's meaning? Unbalanced means not balanced. Then something should have been already balanced. After balancing that something, it depends. Excess is unbalanced. Excess is unbalanced. Okay. So something like this. Right? Let's say I'm taking an object. This object is kept over a surface. Object is kept over a surface. You're going to apply a force on this object. I term this as the force applied. Force applied. You just apply a force, it won't move. You go home, look at your cupboard, give a force, will it be moving at once? No. It's loaded up. Because of the weight and all, there is a force given by the floor. Because it's on the floor, right? It's on the ground, right? It's contacting on the ground. By the ground, it gives an opposing force over the cupboard. You are giving the force to move to the right, let's say. Opposite direction to the left. Ground is exerting a force. It's applying a force. Where is it exerting? It's applying the force in between. It's a contacting surfaces. In between the contacting surfaces, you can see opposite direction. So opposing force, we term it as a resistive force. It's against your motion. You are trying to move it in one direction, opposite direction, it is giving a force. This is a resistive force. How do we name this resistive force? We name it as the frictional force. Another word, frictional force. So what is friction now? Opposing force. Simply. The force which is opposing the motion of an object. And this happens only when it is contacting, okay? Only when it is contacting over another surface. Right? There are different types of friction. Air also gives the friction. Actually, that friction we term it as air resistance. We don't say air friction, air resistance. Because of the air particles. Likewise, medium to medium, it's different. So when two objects are contacting on one another, one object you apply a force, the second object exerts another force in the opposite direction against your motion. It is the friction. I told you it should be balanced out. Okay? It should be balanced out. One person is holding up like this. You are giving a force to move him. He is strongly staying there not to move back. He is, pushing you back being straight. Now, somewhat if you want to move him out, what are you supposed to do? You have to increase your force, right? He might be having a maximum force he can hold up. You are increasing your force. If not, you are accompanying with some more people. You are increasing your force. At a time you can see, okay, when you keep increasing your force, he has a maximum. Up to that maximum when you reach, you can feel now the person is ready to be pushed back. You can feel that, right? Some more you give the force, you will be pushed back. Correct? So you see, at that time, he has the maximum friction. I mean, like an object. Opposing force is maximum. Now, the force he gives in the opposite direction and the force you give to move him become the same. Correct? Equal. More than that equal amount, some more force you give, some more additional force you give, you can see he will be pushed back. He will be pushed back. Am I correct? So until then it was balanced. After the maximum opposing force, what is the excess you are giving becomes unbalanced. Correct? Correct? It is called unbalanced. Likewise. Force applied. You are increasing. Friction also increase. About the types of friction, the next part will take. Okay, there are three types of friction depending on the type of motion and up. Okay, so just the word friction here. More than the maximum friction, you are increasing your force. The excess of the force act as unbalanced. So the object moves further because of whom? The unbalanced force. Unbalanced force. You understand that point? Is that point clear? So this is how the unbalanced force comes. Unbalanced force. So, example. You can see over their screen behind. There's a person trying to push a table or a desk. Okay? That is the force he is acting. He's applying on the object. He's applying the force. Now the ground is applying a force on the desk, right? That would be in the opposite direction. So that is the force given by the ground here. You can see it is given in the opposite direction. You are giving in one direction, opposite direction, the friction is given. Now, when you overcome this opposing force, excess becomes the unbalance. What will be its direction? It will be in the direction of the force you apply. It will be in the direction of the force you apply. Accordingly, the object keeps moving. So how do you find out this unbalanced force? The unbalanced force is equal to the force you apply. If you consider as the positive direction, because that is the direction unbalanced force should be moving, right? Frictional force should be the opposite direction, minus. Minus. So how do you find it? You see, unbalanced force is equal to what is the force you apply minus frictional force. What is the force you apply minus frictional force, whom you can find out? You can find out unbalanced force. Unbalanced. Alright. Example. Let me take an example like this. It's an object. You are giving a force. Skip to a surface. Opposite direction, another force is given. Opposite direction, another force is given. Okay. Now, let me take it as the force you gave. The force you gave is 150 Newton. Opposing is 120 Newton. Then how much will be the unbalanced force? Unbalanced force will be equal to how much? 150 Newton minus 120 Newtons. So how much is it? 30 Newtons. 30. Is that clear? A very simple theory. Very simple. So always remember, an object moves because of not the total force you apply, but the unbalanced force. Unbalanced force. Questions basically go up with this unbalanced force. And all the laws of, our topic is laws of motion, right? Related to this. So all the laws are moving up. There are three laws. All three laws are moving up with this unbalanced force. Excess force. Clear the point? Clear? Right. Shall I take the note quickly? Go to write and work. Take the topic force. Take the topic force. And right there, force is simply a pull or a push. Force is simply a pull or a push. Yeah. Go to write and work. You can draw this. Take the note down first and then go to that part. Very fast. Take it as an example. Fine. So is this person? Fine. The person who is getting scolded by most of you people always, isn't it? Yeah. Always is a person nicely getting scolded. Still the class is going on, no? Fine. Remember, if this person was not there in the general world, okay, lot of theories might have delayed to form, delayed to be discovered. A lot of the inventions could have got delayed if this person was not there. Because he has invented a lot of theories, the fundamentals. Fundamentals. Because I told you, without the fundamentals, you can't build up the building, right? Okay. So fundamentals were found by this person. Right? Because of him only the science is easy. You know what? Because imagine now, he didn't find it at that time, right? The apple has been fallen down on someone else's head, like you guys. What happened? You will just take it, pick up, eat it, and go. That fellow was thinking about what it is, how it happened, what caused this, right? And he came up with an idea. He ended up with the theory, gravity for the first time. If it was not done at that time, it might have delayed 5 or 10 years. We don't know. Or even 1 year, let's say. What happened? All the discoveries would have delayed by another 1 year, right? Isn't it? Everything goes parallel, right? If you couldn't do something on time, the other day means 1 day you are spending to do that, right? In vain. By 1 day you are getting delayed, right? Or else you have to compact all your works by 1 day, reduce, isn't it? By the deadline is reducing, isn't it? Likewise. So he has done a lot of. What's his name first? Yeah. Now, the same question was asked by one of my teachers. Okay, when I was in A-levels. What is the question? He was asking, who found gravity? One of my friends was saying, Newton. Newton. Newton to bappa, he was asking. I was wondering what's going on. I was saying, Sir Isaac Newton came up. Sir Isaac Newton. But that the sir was not given as a title or something, as a honor. He's not, it's not his surname or his name. A honor, a respect. Why? A lot of things he has done. We are giving that name. Sir Isaac Newton has. Clear? Clear the point? So the honor should be given scientifically, and it's because of they have done a big work. Does it mean that others have not? So we don't say sir for them. No. Depending on the works and all, depending on the ideologies at that time, how they were called, the name has been established. It is a brand name. Sir Isaac Newton was right. So Isaac Newton, anyhow, Newton's word we are using when we are calculating, because as a honor for him, the Newton is used as a symbol for the measuring unit. So this person has found a lot of theories. One of the theory is the laws related to motion. Laws related to motion. So 3 laws are there: the first law, second law, and third law. The first law says that, read, until an unbalanced force. I told you all 3 laws are going up with this unbalanced force. So until an unbalanced force is acting on an object at rest remains rest. An object at rest remains rest. Let's say this object. The object was at rest. Unbalanced force is 0 means it doesn't mean you don't apply a force. You are applying a force. You are giving a force. But it has not overcome the maximum friction. Unbalance is 0. You understand the point? You are giving a force less than the maximum friction. Less than the maximum friction. So you haven't overcome the maximum friction, so you can't move the object. So there is no unbalanced force. So if there is no unbalanced force acting, object at rest remains stationary. This is the first part. And an object in motion, it's already moving. Let's say speed is v. You are giving a force, but it is not unbalanced. UF is not a standard symbol. I'm writing it short, okay? Right? Unbalanced force is 0. So object in motion moves at the same velocity, uniform velocity. Already it's moving. Imagine an object is moving in one ball. A football is keep rotating, falling. You hit it onto the same direction, it increases the speed. An object moves on in the opposite direction, you are giving a push, it reduces the speed. So you see an unbalanced force you give, you can change the speed. As far as you don't apply an unbalanced force, object at rest remains rest, object in motion moves at the same pace. Right? Now holidays, during the holidays, this happens in the morning. Right? You keep sleeping. You keep sleeping. Mom says, wake up, dear, wake up, wake up, wake up, wake up. The sound increases. You are still sleeping. Okay, you are at rest. Suddenly, something is coming towards. The spoon from the kitchen flies over towards your face. Huh? The slippers from the shoe rack coming towards your face. An external force. What happens now? Water experience. What happens now? Now you change the position, right? Until this happens, you were at rest. Am I correct? Until this happens, you were at rest. You were at rest. So you see, object at rest remains at rest as far as there is no unbalanced force. Okay? Unbalanced force. And now you are doing your work. Something your mom says not to do, not to do. You know, something said no, you definitely do that. Your mind cannot accept that. Correct? At all this time. Right? Your mind cannot accept. It's a subconscious. Yes. Don't think about a lion now. Lion came to your mind. Why? I said no. I said no. What you are thinking? Don't think about an elephant. Elephant quickly came to your mind. Right? Mind can't accept don't. Negative commands quickly it won't take. Yeah? So we are fooling ourselves saying that don't and can't. Huh? We are saying no sir, I can't. No sir, I don't. You are fooling yourself. Your mind can't accept that quickly. No, 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 it can't accept. No means yes, it does. It does. And that is why teacher says not to do. You are trying to do it. Someone is saying not to touch that. You are waiting until it goes to touch and see what it is. Isn't it? That curiosity is there given by your mind. Okay. Okay. Your laziness, inactive nature is what saying no, no, no always. So you see, fine, anyhow. Now you see, mother says no, 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 no. Still you keep on doing at the same rate. Once the mother comes, yeah, you are running away. Correct? You see, then only when an unbalanced force is acting, only you are changing. Otherwise, you keep doing the same thing, right? Same speed. Likewise. An object at rest remains rest, an object in motion moves at the same velocity as far as there is no unbalanced force. If there is an unbalanced force acting, that changes. Changes. This is the first law. First law. You may think so. You may think. Anyhow, we know this one. Yeah, you knew this. Practically, you knew this, but as a theory, you didn't know. Until the people they had mothers did the same thing for them, but they didn't know this. As an example, I'm saying. They didn't know this as a theory. Theoretically, it is formulated by science. Got the point? So this is the first law. First law. There are many occasions where we are using this. One example only I called. Let me see. 4 examples I have given you on your. Number 1, it's the carom disc. Now the carom board you take, you keep the carom disc there. The other discs are there at the center. Now looking at the carom disc, will it be moving, Rakib? Sorry. By your face, by your eyes, you are giving a force. Will it be moving? It can't move. You have to hit it on, right? You have to strike it on the carom disc, correct? When you give an unbalanced force, it moves. As far as you don't give an unbalanced force, it won't. Anyhow, to reduce the friction, you see the friction. To reduce the opposing force, only you are putting powder, right? What is the powder? Pyaz baking powder? Boric powder. Talcum powder. Pak powder. Talcum powder. Boric powder we apply. Okay? So it reduces the friction to make it more smooth. Right? Anyhow, you see one example. Unbalanced force is acting. You are striking on the disc, so it moves. It hits on the other discs, they are moving away. Right? Right. Another example. Now all you people should have moved on a bus, right? Let me take a bus. Yeah. Right? Thank you. Just around that. Rectangle? No, it's a cuboid, man. Okay. Now, Rakib, you are standing here. You pass a ball, I hit it. You are standing there. There's a big-headed person, not holding up any support. Right? Sudden break. And his friend, Abdullah, is not there. Very, very thick friends. No? He's looking at, you're standing, just showing off. Right? He's already moving. Okay. He's already moving. He was looking at Rakib is not, he's not holding up any support. What he does? Sudden brake here applies. You stop. But this one. Right. Falling. So knocking the face, knocking the nose on the red, coming up with source on the nose. No? Why? What's happening there? First look. First look. I'll explain. Fine. Now he was staring at that person and somewhat getting up. Like nothing happened. 1 second he's standing. Nothing more. Now, because the icon is just standing. This fellow looking at us. Again he was standing. No idea to support. He was stopped, right? Bus was at stop. It was rest. Now what he does, at once he's accelerates. Now what happens? This fellow moves backward. Okay? Knocking the head back now. What's happening? This happens in your life. Okay? Basically the boys. Right? Basically the boys. Just to show up with the girls, they do this, no? Isn't it? With the buses mostly. So then hitting on the nose, that nice showing move. Nicely showing move. Right. Fine. Anyhow, look at this. What is the theory? This theory is already said by Isaac Newton. He said. Okay. Example. Okay. Example. He didn't speak about the bus and it's an example that we are applying. Now you see, everything, whatever is there inside the bus, will get the velocity of the bus when the bus is moving backwards. When the bus is at rest, it's zero. All of us staying inside will be having the same zero, including the gadgets, all the tools, the people, everything, bags, machine, everything will be zero. When the bus is moving, let's say 50 meters per second, the same speed we will get. Now, when the bus is moving at the beginning, all of us are having the same speed, right? And this fellow is standing on the floor bed, right? Now, only the lower part of the body is contacting with the bus floor. Okay, the floor bed, only the lower part is contacting. The upper part is not holding up any support. When the bus is moving, entire body has the speed, same speed. Now suddenly the bus stops, right? Suddenly the bus stops. That means the speed reduces up to zero. Only the lower part is contacting with the floorboard of the bus, right? The floorboard of the bus, only the lower part is contacting. So only the lower part obtains the zero velocity. Why? Stop means speed becomes zero, right? So the speed reduces to zero is given only for the lower part of the body. Means the upper part of the body still has that speed. Because to make it zero, you are not holding up any support because we are taller, we are having a height. Okay. So the upper part of the body still having that velocity. What happens? There will be a force given, an unbalanced force given forward now. Why? You are having a speed forward from your upper part of the body. Only the upper part won't be getting separated and moving on, right? Okay. So upper part, from the upper part, there is a force given. Unbalanced force. So what happens? Because of the force, now moving down. Moving down. If the speed was very high and the sudden brake was at a random, it happens. Sometimes the flying. That happens when in the moves and suddenly moving through the windscreen. That happens. So that much it might not be, but still the theory is this. Right? Now, what happens when he's standing and the bus moves on at once? Bus was at rest, entire body was rest. Speed was zero. Now, once the bus started to move, speed is increasing, right? That the increasing speed is given to the lower part of the body because it is on the floorboard. Upper part is still zero. Upper part is still zero. That means on the upper part there is no force acting. Unbalanced force is zero. It tries to remain rest. Lower part is moving. So the lower part moves, upper part tries to remain rest because no force is acting. What happened? It happens like this. Someone is like pulling your leg. So you are moving. You are moving. So these are examples over first floor. Clear the point? So when someone is falling like that, think about the first floor. Think about the. I have done that. I have done that. No. Some sort of experiences are there. I don't think about sharing that. That happened for me because that is how I learn. I don't remember once. I don't remember once. Okay. I was loaded up some goods when I was actually maybe 10-15 years back. When I was learning about these things. Right? Now we learned about this force and all, but I didn't know what is exactly a force is, what is how it happens and all. I was loaded up with some goods. Okay, a bike came, one of my friends. Okay, those days the maid bike was there. You could have seen even now. The back part is totally a box shape. He asked me to get it. Okay. I just took over. Just being seated, he accelerated. Okay. Now I couldn't hold up because both the hands. I was flying back. You know what I was thinking at that time? Is this what we say as flying? I was falling down. I was thinking about this. This is the look, right? So what I say, that's because of injectable. It's not a boost up or boost up story. Really, what happened? Different, some sharings are there, some thoughts are there, like that, like that. It's a real story. Now you see, what happened? I just thought about, is it what we say as flying? Is it what happening with this? Same thing. Even when someone is falling, you have to help first. That's a different story. First, you have to help. After that, think about what Newton said. Okay, clear the point. Otherwise, brother, sister falling down, you are looking at this is what Newton says. Okay. After that, there will be another law from your mother. Okay. Every action has a reaction. Third law will be in action. Okay. Fine. So this is about the first action, first law, and 3 examples we took, and the 4th example. Seat belts. No, seat belts. Why do we have the seat belts? Is it a tradition? It is a protection. Why? Suddenly, crashes may happen. You have to give a sudden brake. You're moving at a high speed, suddenly you brake. But your body is still having the speed. Because you get the speed, right? Because with the car, no, you are moving. You won't be moving forward and backward with the car, right? I mean, car moves forward, you are still in the back. You are running behind the car, or you are moving first, the car comes behind. All right. You are inside the car, you are getting the same speed, right? Suddenly the car stops, means car gets the speed 0. Entire part connected becomes 0, but you are not connected. So seat belt you are not wearing, what happens? You go forward. Knocking the face of the windscreen. Right? So it happens, the passenger. To avoid that, you do have the seat belt. Even wearing the seat belt, you are going forward and coming back, right? Because the seat belt avoids you going forward. Now, what the people do? There is practically when you are applying properly, practically you have to take. Some people they are moving around like this, like a handbag. Seat belt. And you have some they are moving like this, just because they don't like to put it. Okay. What happened? Will it be protecting you? No. Some what they do, playing up with like suddenly a car crash happen, not because of the crash is dead, but because of this, right? Those with the imagine it's totally connected, it's moving forward. So practically you have to apply properly. So you have to move it around. That is why it is fixing over there in one line. Coming from over there in an angle, in a diagonal comes on and you have to connect. So it's to protect you, prevent you from falling forward. Falling forward. Airbag, what it does? During a crash, when the airbag comes out, it goes up with the momentum change. Actually, momentum you'll be learning later. It reduces the impact time, the time to react. Why? The airbag comes out, keeps you blocked from moving further. So the impact time would be reducing. The reaction time would be reducing. By reducing the reaction time, the damage caused for your face, for your body will be reduced. That is what is happening by the airbag. So accordingly, it is a protective measure. Protecting. So these are your examples where the first law of Newton is acting on. So let's write there. Get your tip. What do you do? What do you do? Yes, you write there. Until an unbalanced force is acting on it. Until an unbalanced force is acting on it. Until an unbalanced force is acting on it. An object at rest remains rest. An object at rest remains rest. And an object in motion, stationary means also rest again. And an object in motion, moves at uniform velocity. Object in motion moves at uniform velocity. Right? Object in motion moves at uniform velocity. You have to memorize this view. Okay. First law, third law is theory. Second law is a calculation. So at the next class, second law, third law, which mass and we will be taking. So please refer the book and come. Make sure totally you are revising. Guys, wait. Only this part you have to copy down quick. Take the first law on your writing book, notebook. Go to writing book. First law, mark it down quickly. It gives a summary about the law. So memorize the first law. Okay. All three laws we have to learn by heart. And give it now. Next class will be. Fine. So that's it about the first law here. Next, we have to move up with the second law and the third law. Okay.